Okay, so welcome everyone to the second meeting of our Instructor Training Center classes. In particular, this is our Introduction to Networks class, and we are meeting to start talking about Chapter 1, Chapter 2, and move forward as we're getting going on the class. A couple quick things I want to show you. I want to make you aware of where you can get Packet Tracer if you are not already aware, and also where your students can get it. So I'm going to turn off my camera as soon as I share my screen here so that I won't be using bandwidth just to have my ugly little picture in the way. So I've stopped my video. I do have the chat up, folks, if anyone wants to chat a question or if you have any issues, and you also can take yourself off mute if you would like to. So our class obviously is the KFC ITC Intro 2019. I click on Launch Course. If you need to get the packet tracer for any class or your students need it, they will go to Student Resources and you will see a link to the packet tracer resources. You will also see a little Introduction to Packet Tracer course. If you have time, this is not a very long course. It's about 8 hours, 8 or 10 hours. I strongly recommend you actually do this little self-enroll course. If you click on it, it's going to take you to it, and you can actually sign up today, and that will do a self-enroll, and you're able to take that Introduction to Packet Tracer course yourself. If you're just wanting to get the Packet Tracer download, you click on Packet Tracer Resources, and you'll see your downloads. The current version is 7.2.2 for English, Linux, and Mac. In fact, I'm going to go ahead and download the 64-bit 7.2.2 because I don't have that on my system.
Excuse me, Kelly?
Yes.
I have never taken the Packet Tracer course, and I don't have a spare 10 hours to do that. Am I going to be able to just do what I need to do within Packet Tracer following the directions that we have?
Definitely, definitely. Yeah, you don't have to take that. You'll definitely have what you need to do. Because all we're really doing is working through the packet tracers that they give you, and they're not asking you for anything really weird. So no, you'll be fine without doing the class.
Okay, thank you.
Mm-hmm. But that's where you get it. Student Resources, go to Packet Tracer, and then download it. Now, one of the things I've had some questions about, what do we want to be displayed or what needs to be displayed on the packet tracers. Some of these packet tracers, folks, are just what I call look and see packet tracers. There's not much you can do, especially with this first one. When you go in here and the packet tracer is literally just looking around at the interface, you're not going to be able to do a check results and see anything on this packet tracer. As you move forward, however, okay, as you move forward into Chapter 2, and you get into packet tracers that are going to ask you to actually do some type of well, navigating iOS won't do it. Let me go down one more. Ask you to do some type of actual configuration. You will have a check result. So here we have basic connectivity. If I open this one up, I'm going to go ahead and open it. And it opened on the other screen, so I'll pull it over here in just a second, folks, so you can see it. All right, let me pull this one over here. Click OK. And I pull this one over here and make it full screen, and I pull over the directions. You'll see that on our directions here, we have, pull this on up, several things. It's going to ask you to perform a basic config on switch 1 and switch 2. And you'll see right here, completion, 2 of 88. So you've already been given 2 free points. But I need to configure a host name on switch 1. So I can click on switch 1 and go to CLI. Okay, and I'm going to pull this, oops, and pull this over here on this one, and I'll pull the activity over here.
I'm sorry, I didn't see where you could check results, or, oh, I see it now. Okay.
Yeah, hold on one second. I had it all there, and I messed up. It's down there, see where it say check results?
Yes.
Okay, so I'm going to put this one in this upper corner here, and I'm going to click back on switch 1, and it'll be there, and I need this thing to be away. There, okay. So I'm going to go into the switch itself, go into what's called privileged exec mode, go into config mode, config T, and I'm going to put host name S1. Now what should happen, as you noticed here, that went from 2 points to 3 points.
Where is that?
Right here on the far right hand side, so where it says completion. I have 3 points now because I put a host name in. Now watch this. It says
Okay.
configure the console and user exec and privilege exec mode password. So I'm gonna go ahead and do this. I'm going here and go line con 0, which is line con 0, and pass Cisco, and then log in. Now look what happened. I now have 5 points where I had 3. And in fact, if I click check results, one of the things that's kind of neat about this, where did it go? But I know it's there. Where did my check results go? Come on. Here it is. Okay. On check results, most of these items will have this assessment item, and you actually can look and see all the different things you're supposed to do. So I can see here on S1, I've been given credit for the host name. I've been given credit for the console line, password, and login. And this is all the things I need to do to get 88 out of 100. And then when I'm getting ready to finish this lab and I want to turn this lab in, this is when I just take a little snipping tool, take the snipping tool. And my machine is acting extremely weird, folks. It's being very slow this afternoon. I just had a web browser crash, so. But I just come over here with my snipping tool. I take a snip of this, and then you can upload this with your PKA file, and then I can see what you actually made on it. Like if you uploaded this, I'm going to say, hey, you know, you didn't really do the lab, right? I would question this. I'd say you haven't done everything. So I would obviously say you probably want to go back and do this one again, or are you having problems with anything that I can help you with? So this is what I mean by taking a snip of the check results and uploading it with your packet tracer. Are there questions about that?
Kelly?
Yes.
Can I go back, when I'm all done with the packet tracer lab, I do a save as or a save?
Yep, that's correct.
Okay, and then, does that mean I can go back in and look at this?
Yes.
Check results?
Yes. Now, quite honestly though, if you have not done this for the ones you've already turned in, do not go back and do it. Okay, don't feel like I'll just open those all the way up. The difference is if you don't do this, I have to open them all the way up and look at them, but that's fine. That's fine. If you haven't done it, go ahead and do it.
Yeah, I don't even remember seeing the score or any of that when I did my one lab.
Okay. Well, like I said, on some of them there won't be a score. For instance, if I go back.
I'm not talking about chapter 1. I'm talking about
chapter 2. Okay. Okay.
Yeah, I'm talking about the one you're on at the moment, this very first one.
Okay. Well, like I said, you can go back and open it up, and I can also check later and tell you. I mean, but you can if you've got them saved locally, you can just open them right back up and do a check results. The only thing I will tell you is sometimes if it is a packet tracer that has one of the PCs is using DHCP, sometimes you will not get points for that packet tracer simply because it takes it a little while to do the DHCP request. So you may have to actually go in and do an IP config/renew on it.
Yeah, no, it was a static IP.
Okay, well then it should come up fairly quickly if you do that. Now, once I close the check results, I'll be right back where I was. I've got my configuring and the other items, so I can just keep doing my work, getting my points. So again, I'm gonna go over here to S1 or S2, and I'm going here and I'm gonna go to privilege exec mode, config T, host S2. All right. Line con 0, login. Really, you should do login before you do the password, but actually password before you do login. And it didn't even tell you that. And now I'm up to 8 points out of 88. And then I can go enable secret. And what do I want to enable secret to? Class. And boom, I got 9 points. So you can just keep going through and doing all these and get your points. So that's kind of neat. And if you ever do get stuck, folks, and you don't know why you're not getting points or you don't know how to do an activity, you can kind of semi-cheat by doing the check results, and it'll pop back up here in a second, and let those check results tell you what it's looking for. That way you can actually look at the assessment items and see what it's looking for and go, oh, okay, that's what it is. I'll also warn you this. Packet Tracer is a wonderful tool, However, when you set up these self-grading items like this, many times you have to be super specific. So if I had used lowercase s2 instead of uppercase S2, it may not have given me credit for it. That's kind of important too, because Cisco routers and switches in the iOS are in case sensitive. It's important you understand that. I've also had a great deal of problems with the message of the day. So if you're doing a lab and you cannot get the score for the message of the day to work, just put a little note and say, I couldn't get MOTD to work, and I will know it was a packet tracer quirk. There's one or two of these packet tracers that have that issue throughout the entire curriculum. And they fixed some of them, they haven't fixed others. So just be aware, if you're doing the banner message of the day and get that, just ignore it and move on. So don't get hung up on that. Okay, any other questions on the packet tracers before we move forward? All righty, I'll stop that right there. Any questions on chapter 1? Obviously, there were no net labs that you needed to do. I'm going to do a real quick overview of the chapter 1. I'm not going to spend a lot of time here because I believe most of you probably taught networking for a good while. If you have not taught networking for a good while, or if you just absolutely know nothing about networking, please let me know, and I will adjust things as we move forward. Otherwise, I'm going to assume that most of you know what a LAN, a WAN, a MAN is. One thing that we don't talk about in the curriculum that I always love talking about is how many of you have heard of a PAN before? P-A-N. Anybody?
I haven't.
Have not. Okay. It is called a personal area network. And what is interesting is personal area network. They're becoming more and more available as we move forward, because think about this. How many of you wear a Fitbit? Have you heard of Fitbits?
Yeah, I have an Aura ring. It's similar.
Okay, same concept. So in other words, what you're doing is you have a network between your Fitbit and your phone that's monitoring all your steps, everything you're doing. It's monitoring your heart rate. It can monitor heart rate anyway if you set it up that way. Back before I got hit by a truck, I actually used a heart rate monitor, and I used this really cool system that actually, it's kind of scary in some ways, but it tracked me. It used a GPS on my bicycle computer to track me, keep up with heart rate, keep up with everything, keep up with power, and it actually showed me on a map. And it was honestly one of the ways my wife knew something was wrong, because I was stuck in the same spot for an hour and 10 minutes when she got back from her run. But these personal area networks are growing more and more. We've got folks who have diabetes who have these insulin pumps that are mapped to a device on, a phone app, which also is looking at another app that's sending their blood sugar levels and automatically increasing or decreasing insulin, depending upon what they need. So these personal area networks are becoming more prevalent. They're also seeing some use in the military, where it's going to be like the Aliens movie, where you're literally going to be able to track, individual soldiers and where they are and their heart rate and what's going on, to try to help with if they were injured, wounded, taken prisoner, any of those things. So these personal area networks are very interesting. Our homes are so networked now versus what they used to be. You think about how many out of the 4 of you or 5 of you are here, how many of you have at least 10 devices in your network that are in your house that are connected to the network?
Yeah, I do.
Oh, I know I do.
Yeah.
I mean, you got a couple phones, couple laptops, couple gaming devices, Sonos, couple Google things, I mean, by the time you count it, probably 20. But it's amazing how fast, I hate to say it, but you talk about lazy, the whole concept of, hey, Google, turn on the living room lights. That sounds crazy. In fact, I'm on my phone trying to turn on my living room lights. Stop it. But it's kind of nuts that we're able to do those kind of things. And really, it is the future. I mean, when you think about the house where we can sit and talk to the house and, It's almost like Star Trek. Well, it is like Star Trek. I'm just waiting for the device to be able to make things automatically. What is that, golly? I'm drawing a brain fart. Oh, well, sorry. But they've got a device that makes things automatically, and you can just ask for tea Earl Grey, and you have it.
Replicator.
Replicator, thank you very much. Golly, long day. Do we have any questions about peer-to-peer versus server-based networks? Are we fairly, I do want to go over if you're not familiar with it. Pretty well known, okay. This is something important to know, and that is these different icons. The icon of the multiple arrows going different ways, that is a switch. The round item with the icons the way that is a router. So those are common icons used in the curriculum, throughout the curriculum. So they talk about the three things that a network normally has, which is, I usually the way I say it is, I say all networks have something to share, some way to share it, so a media or medium, and then a protocol or a way to share it. They're a little bit different. They say there are devices, media, and services that are available. So devices, media, and services. And that media, don't forget, can be copper. It can be fiber. We were trying to hook new servers up just last week, and sure enough, didn't have the SFPs we needed. So I had to do a special quick order for some SFPs. Needless to say, it was aggravating not to have that, but you learn. End devices are the actual devices out on the end. That's computers, printers, phones, fax machines, any of those. Intermediary devices are our networking devices. So here, one other device you'll see pictures of in this curriculum in particular is this item right here, which is a multi-layer switch. We will see wireless routers some. We rarely see the firewall appliance in this particular course, or the CCNA sequence. We see it in the CCNA security and the CCNA cyber ops sequence.
Kelly, when do you use the multi-layer switch, out of curiosity?
Okay, honestly, 99% of our switches are going to be multi-layer switches.
Okay.
Well, I won't say it. I'll say 80% of them will be multi-layer switches. So we normally have, when you look at a network design, many times especially when you look at Cisco.
Attention, please. United Way election form, if you need another one, we have been given till tomorrow. I forgot about it Friday.
I just muted somebody. So in the Cisco world, we usually have a core layer. We have a distribution layer, and we have an access layer. Typically, anything from distribution layer up is considered a multi-layer, so it can do layer 3 routing. And I'm going to unmute everybody I just muted. Sorry about that. But if you don't want yourself unmuted, just mute yourself back. But so the distribution layer and the core layers are typically multi-layer switches, and so they can do layer 3 routing. Access switches are not considered to be layer 3 most of the time. So I would say for most of our switches, we do have multi-layer capability, especially this day and age.
Okay.
Now, in this curriculum, we do not. The 2960s we are using are access layer level switches. So we will not be doing a great deal of layer 3 with this. There is a little bit in the second course, layer 3 switching with the 2960s, but you have to load a special SDM on it, and we'll go through all that when we get there. Okay. Did that answer your question, Will?
Yes.
Okay. So our media, copper, everything from category 5 to category 7, shielded and unshielded twisted pair. Fiber optic comes in two really basic types, one being shortwave, long range, and short range, and basically one is made out of, well, almost everything now is made out of glass, but it's depending on what type of lasers you're using, whether you're using a laser or LED, and that can get into a lot of complicated items there. And then obviously wireless, which has many new standards coming up. And I think the biggest thing with cabling that you need to think about is how far can the signal go? How secure do you need it to be? How much can you pay? I mean, in a perfect world, we'd run fiber to every single device, but that's expensive. It's not as expensive as it used to be, but it is expensive. So that's something to consider with your layer 1 device or layer 1 media. Here's our different items I've already talked about. It is important to see this cabling down here. This is a wireless cabling, this little multi-frequency thing. LAN media is shown by a single black line, and then WAN is this serial link. And we'll talk more about this, but this is typically a synchronous connection between two devices. We do have a network interface card on our devices, and we have a physical port called a transceiver right here. And this transceiver typically converts from RJ45 to some type of cable, be it Cat 5, 6, or 7. Or it could be a transceiver that was fiber or SFP. Are any of you familiar with SFPs?
No.
We're doing SFP plus. And they come in all different varieties. But when you look at an SFP, these are SFPs and they're made to slide into switches. So let me do this right here. I'll do another SFP plus switch. So you've got these switches, and the switches themselves have SFP ports. Okay. So those 12 SFP ports right there, and I know I can't zoom in on it, but they're just square little ports, and then you buy an SFP to support the type of cable you want to put in there. So if, let's say those ports were 10 gig ports, which these are 10 gig ports right here, 10 gig SFP plus, and you want to use Cat 6 shielded cable to be able to do 10 gig connection between two switches, you would buy 2 of these SFP 10 gig T, okay, modules right there. And these are Cisco compatible, so they're about 3/4 of the, well, they're actually less than that. They're about maybe 1/5 the price of a Cisco. And you can see it's just a little square item that you could then slide into that port right there, put one on the other switch, and connect 2 cables, 2 Cat 6 shielded twisted pair cables, and you would have a 10 gig connection between the 2 ports. Now, the neat thing about this is with the SFP ports, we can use different types. So if we didn't want to use copper, if we wanted to use fiber, we could buy a fiber. Here's a SFP plus short range. So this will be a short range fiber optic. I call it SR short range, but that is. Here's again a 10 gig RJ45. So on modern switches, when you get to buying them, here's coax. This is our twin ax. This is you can do SFP twin ax, and it's compatible with this, compatible with Cisco, and it usually will do 10 gig easily. So instead of having to put your own cable in between it, you use this twin ax, and you just slide it in here and slide it in the other side, and bingo, you got you a 10 gig connection. So SFPs do come in all types and sizes, and one of the problems that you run into, which is what we ran into last week, is we had the switch, we didn't have the SFP to be able to make the connection. So be aware on modern switches that this is something that's going on. On our switches, on little 2960s, we're not worried about it because our 2960s all are RJ45, 10100, 1000, or just 10100, honestly. Did that help a little bit with SFPs?
Yes.
Okay. How about this? How many of you are aware of the difference between the physical topology and the logical topology? This is an important concept in networks because physically we may connect our devices in a star or a star wired mesh or star wired bus, but logically the devices are broken up based upon their IP addressing. So in this case, you'll see we've got the 10 network, the 100 network, and the 11 network. But when we look at it physically, it looks like all of these are in one server room, and this is in a room, and this is in a room, and these are in all these rooms, but logically they're in different networks. We got 100, 101, and 102. So even though physically these are all in the same room and these are in separate rooms, these are different VLANs that we have, or different networks we have available because of our networking. So the physical topology is the way the cables are physically connected. The logical topology is the addressing scheme and how data is going to move in our network. As we learn more about networking and more about IP addressing and subnetting, we'll understand more about why this is in fact they're different here. Because every device on the 100 network cannot talk to any device on the 101 without going to the router, without being routed. Any questions? Okay. We talked about the different types of networks. So I'm going to blow through these. What's the biggest wide area network? Anybody?
Internet?
The internet. Yep, that's the biggest wide area network. Very good. Connection options for our home and office cable. DSL, I have 10 megabits per second and it kills me. My internet is so slow. It is just aggravating beyond belief. I cannot get cable where I'm at. It stops 1/4 mile to the right and 1/4 mile to the left. And so it's so aggravating. Cell service, I'm hoping maybe when 5G comes in, I might be able to put a 5G access point in the house. What I'm really waiting on is I'm waiting on Starlink from SpaceX, and I'm going to get satellite connectivity to the SpaceX Starlink setup. And if you haven't heard of Starlink, you just go to Google Starlink, and it's the constellation of low orbit satellites for internet access that SpaceX is putting into orbit. They've already done, I think 60 were launched earlier in the year, and then they're getting ready to launch 60 more in October, and then they'll continue to launch 60 with each launch. Dial-up telephone, I hope you're still not doing internet access that way, but it used to be an inexpensive way of doing it. It was just unbelievably slow. Out of the 5 of you now, we got 5 in here. Who's got cable? Anybody got cable?
Talking about
Yes.
cable at home?
Yeah, cable modem at home.
Yes.
Yep. I do.
Yep.
All right, so it's 3 of you, and then 3 of us with DSL.
Yes,
No,
I have
okay.
DSL.
Choo. Yeah, I hate my DSL. Just ugh.
I feel the same way when you're talking about your speed. I only get 10.
Yeah, it's so
less
bad. Like
speed.
I can't do these meetings from home because of the fact that there's too much, too slow. This is way too slow. All right, so again, this one packet tracer right here, folks, was just a look and see. Nothing you're going to be able to really turn into me except for the packet tracer with your name on it, and I'll give you 100. That's not a problem there. And the same thing with the representation on it. I will say this is something that is not very new. It's been going on for a long time. It's the convergence or a converged network, but it makes the network so important now. Imagine if your phone system and your emergency broadcast system all go across your network now, your computer network, instead of across a different network. It's super important that that network is up at all times. If you lose power and a switch goes down that's running your telephones, and then people can't call for help, then you've got a big issue. So it's really changed the way we've designed our networks. We have to put UPSs now on our switches that have power over Ethernet, because those switches power our telephones, and those telephones are needed to be able to call in the event of an emergency. They also power the IP cameras that are there to help in the event of an emergency, or the broadcast system. So traditional separate networks have gone the way of the dodo bird, and now we have converged networks where everything is going across the network, typically using IP, TCP IP, as we will learn more as we move forward.
So with that many things going on, are they going to go to version 6?
I couldn't hear you.
With so many things going on that network, are they going to go to IP version 6?
IP version 6. That is a very good question. The answer is yes, we will eventually. The problem in the United States is you have to give the ISPs a business reason to do it, to endure the pain. You know, most of our networking devices that you have at home, even your routers at home right now, will support IPv6. The question becomes, do ISPs want to convert everything to IPv6 and deal with that problem? We should have gone to it years ago, quite honestly. I mean, IPv4 has been out since the 90s, but we've been able to continue on by doing, natting everything. I think I keep saying this. I said this 5 years ago, and I was wrong, so I'll fess up. I think in the next 5 to 7 years, you will see it. I think it's just a function. It's got to happen. So many devices are going on the network that there won't be an option. We're going to have to use IPv6 because of its greater numbers. All right. I'm going to blow through this. Reliability, you know all this stuff. Security, scalability. Trends, I think one of the biggest trends is the phone, folks. I know people who don't even have a computer anymore. All they have is a phone, especially younger kids, and they think that's all they will ever need. And honestly, it might be all they ever need. Some of the days, my phone, it's really kind of scary. I can do 90% of what I need to do just on the telephone, which is, again, pretty scary. But it also brings in some massive security problems because I'm hooking this phone up to the campus network. And what's that going to do for the campus network, even if I'm on the guest network? So this BYOD, or bring your own device. Online collaboration, here we are, folks, we're together. You're not sitting in a classroom. You didn't have to pay to come to Stanley. Now, I'll be completely honest with you. I would love for all of you to come to Stanley and sit in the classroom and let's get together and have a class. I wish we could do that. That's how we used to do all Cisco classes, all our online classes with instructors. That's exactly what we did. The problem is your schools don't have the money and you don't have the time. So we're doing online collaboration in this way. I do think it works. I just don't think that I can I like building a classroom spirit and an online class environment. And so it's a little harder to do. It's funny, I'll meet some of you down the road. I'll meet you at a conference and you'll introduce yourself and I'll be like, oh yeah, okay. Because I've never seen you in person, which is always kind of weird. Video is huge. Do not ask a millennial to read, send them to YouTube. Of course, I'm the same way. The other day I needed to change the water filter or something in my refrigerator. First thing you do, what do? YouTube. It is like the world's collective unconscious. It's got everything you can imagine. Some things you don't want to imagine, but it's got all the things that you'd want to do. Whenever I need to change the air filter in my wife's car, I had to go through and look at it and remember how to do it again. So it's pretty amazing. But video, one of the things you got to think about there is with an increase in video, what does that do to the network? What are the two things that it causes to be strained or need to be increased? Anybody, Mike?
Bandwidth?
Bandwidth is definitely one. Okay. Sharon, can you think of another item?
Actually, I was about to say bandwidth.
Okay, bandwidth is one, but can you think of a different one? Okay, anybody else? Pamela, Lena, do what?
Oh, I was going to say quality of service.
Definitely quality of service. That is another one, because I don't want someone who's just surfing the net to have the same quality of service as my video. And then one more big thing I can think of. Have you downloaded a video to your desktop lately?
Storage.
They're large. So as we get into 4K streaming video, it increases the need for more storage. Somebody has to hold those 4K videos. Now, thankfully, YouTube is holding it and Google is, but somewhere, somehow, that has to be stored. And so that's really storage becomes a problem, and then high-speed access to that storage.
You know, that raises a question. I've seen students, they think the cloud is a thing. They don't
Yep.
recognize that that's a company somewhere with servers that they have made available through the network.
Exactly. And that's one thing we really need to make students aware of is the cloud is nothing more than a data center that somebody's giving you access to. It's literally compute, storage, and networking resources that you have access to remotely. And they don't really see that. You're right. They don't understand. They don't understand that Snapchat is just a big cloud that everyone has access to. Good point. Now, again, the smart home tech is getting there. You know, I have the ability to turn the lights on and off remotely. I have the ability to look in my house remotely. I have the ability to, by the way, I use a system called Blink, which is from Amazon now. They bought them, which is just a nice little system that's fairly inexpensive, uses AA batteries to the cameras. So it's not something that'll break the bank. But you see more and more home technology and smart homes finally coming together. And it's funny, there used to be a trend, all of these big companies wanted to get into smart homes. They wanted to sell you this huge $30,000 additional package to your house when you built your house. And people balked at that. But now they're bringing in things piecemeal. They're just bringing them in. You know, I'll bring in Blink. All right, that's my quote security cameras, or Ring, or whatever. I'll bring in, Philip Hughes to run my lights. I'll bring in Google Home and Nest to do this or that. So there's all different types of things that you can do using home automation. Do any of you do any of the home automation stuff?
Yes, we do that with my class. to
That's actually a
experiment.
neat thing to do with class. Actually have them do some of it.
I definitely.
Yes, we also use Raspberry Pi as directional devices.
Oh, that's cool. That's very neat. Anybody else?
I do. I
Yeah.
have the Ring. and
Okay.
Light bulbs.
Yep. That's neat.
And Alexa is pervasive. She's eavesdrops on everything.
Oh yeah, she's pain in the rear. That's why we like to turn it off and then turn it on when we need it. So
That's one thing that was brought up at the conference is a lot of these devices still have vulnerabilities that are getting hacked.
a lot of them are very much open to being hacked because they were not designed with security in place in mind. I agree. Here's something that I honestly dismissed completely until I had a student, an instructor who was from New York City, and said, yeah, we use these because in the apartment buildings we're in, the wireless spectrum is so overwhelmed, you really can't use wireless very well. And so they use the power line networking to be able to give them actual wired access to devices in the apartment. And where I live, you know, the closest neighbor's a good ways away. I mean, there may be cows closer than neighbors. So, well, maybe not really, but it'd be pretty close. And so that's never been an issue for me. And so I just kind of dismissed the power line networking, but it is used out there, just not in my area. I'm hoping, and then they throw in some security stuff here, Lord, that's just kind of, here we go. And then there's some, little bit of Cisco marketing, beep, beep, look out for marketing. This is changing. There will no longer be a CCENT, folks. Good news for you is everything that's in this first class is pretty much in the first new class, but there will not be a CCENT anymore. And there's only going to be 3 classes to get your CCNA instead of 4. So you're on your way to get 3 classes instead of your 4 classes.
So have they stopped marketing then to high schools?
The high schools, and actually something that's not known by many, is that for high schools, CCENT is going to actually be available for anybody in the Cisco Academy and Academy only until July of next year. So that way for high schools, it gives them a little while to move over. I think the new curriculum is going to be small enough that they'll be able to teach one and a half in the first class and then 1.5 in the second class, and be able to teach all 3 Cisco classes in high school now, to be quite honest. Can't promise that, but I think that's what's going to happen.
And when you say class, you mean a full school year and not a semester.
Correct. Right. So let's talk a little bit. Any question about chapter 1? I know we've got only a little bit of time here, but I want to talk about chapter 2 a little bit, and we'll keep moving forward. Don't get confused about what a router is, because a router is just a computer with specialized chips in it. That's all it is. You can make a router out of a regular PC with 2 NICs and the Linux operating system. So on a router, you really have an operating system, and you have hardware down at the lowest level, and on a router you have ASICs. You have special application-specific integrated circuits. Sorry, folks, my phone's ringing here. I'm gonna mute this. Sorry, folks, that was one of my other instructors in Florida. So you have the hardware here, which are application-specific integrated circuits. You then have a kernel that's part of the operating system that has direct access to the hardware, typically. So you have kernel mode items that have direct access, and then you have a shell outside of that, which is typically user mode, which are items that do not have direct access to the hardware. They have to go through the kernel to get access to it. This is typical even for operating systems such as Windows and Linux, and it's very typical of what we have on the Cisco devices. We have a command line interface, and that command line interface is available for 99.9% of Cisco devices, and there are some graphical user interfaces for Cisco devices. We use the CLI for most of what we do in Cisco. Our iOS is capital I, capital O, capital S. So it's not the Apple iOS. It's the internetworking operating system. And with it, we do have a command line operating system, and we're going to use primarily release 15.x in this class. You will learn, and you also learn later on how to download the iOS and how to install it and all of those items on a machine. But for us, we're going to be using 15.x on both the routers and switches. When we go to access a router, we can do in-band and out-of-band management. Now, in-band management would be any management over the network. So if we SSH, which is secure shell, or telnet, which you should never do, even though we're going to do it in the class, these two are over the network, so they are in-band management. Out-of-band management is management that is not over the network. In other words, in our case, we'll be using the console port on our devices. Every Cisco device has a console port, and it is easily accessible. In fact, if you don't secure access to the physical console port, no matter what kind of security you have on your device, I can get into it. Plus, quite honestly, the best way for me to do a denial of service attack is just steal all the power cables out from your server room. Think about it. Why would I steal power cables? They have copper in them. I can sell copper. So I come in, steal all your power cables, melt the plastic off, sell the copper, and I make money. And suddenly you are completely, totally out of luck because you have no more power cables. Okay, so you do need to secure physical access to all your devices. When we go to connect to a console port, we're going to use some type of terminal emulation program. I prefer putty or super putty or tab putty. Some people like Terraterm or Secure CRT. There is an OSX terminal, but we're going to connect with putty, and we're going to connect not with SSH. These are all SSH here showing they're doing SSH. We're going to take it and connect via our serial interfaces. You can go through here and do these. By the way, you are in the equipment room with a new switch that needs to be configured. You're going to configure it with the console. The manager gives you a special cable and tells you to configure the switch. That would be console. You access the iOS using another intermediary device over a network connection. That would be here. You call your manager to tell him you can access your router in another city over the internet. He provides you with information to access the router through a telephone. That's the aux. They do not talk much about the aux. The auxiliary port is typically connected just to a modem for dial-up. We rarely do that anymore, but it is possible to do it. These are great items for your students because they allow them to test their knowledge. One thing I will teach you too about the Cisco curriculum. Now let's look at this. So here's our different methods of accessing. There's one time it's mentioned. All right, here's the second page where it's mentioned. And then here's our third item where we're actually being tested on it. If you see it 3 times, it's on the CCNA somewhere, somehow. Be aware of that. When you start seeing things multiple times. Hopefully you've watched this video. If not, then I'm not going to watch it with you. But it told you about 2 different things. It told you about the 2 different methods or 2 different modes of operation. One was called user mode, denoted by the alligator mouth, that's what I say. One was called privileged. I cannot spell privileged. Gracious. All right, I'm just going to mess it up and go for it. All right, and that is denoted by the #. I call the user mode, quite honestly, the look and see, or the read-only mode. Because you can't make any changes. Privileged mode is full access. You're able to do anything. You can make changes. You can go into different sub-configuration mode. For instance, if we have this mode, if it says router, config, #, anybody know what that mode is?
Global?
Do what?
Global?
Yep, that's global configuration mode. Global config mode. You could see a mode like this. Config-if, and that would be what? Anybody?
Interface.
That's interface config mode. You could see this. And by the way, I'm just putting the right name router in because just using it as a base name. You could see config-router. That is what? You really hadn't seen that one. That's router protocol config mode. Sometimes just called router mode, router config mode. And there's tons of others, folks. This one you will get used to doing because it is one that lets you do, that's how you configure the console line. That is, this is line configuration mode. All of these are different modes, but they all descend from user mode, goes into privilege mode. What do you type to go from user mode to privilege mode?
EN or enable?
Enable is the full command. You can shorten it to just EN. That's the shortest you can actually shorten it to. And then if a password of privilege mode password's been set, you will be prompted for that password. If not, then you will just drop directly into privilege mode. These modes are what the video kind of goes through on this. Here's our primary command modes, user exec privilege. Oh, I put an extra L in there. Watch this, I'm gonna fix it. Sorry, there you go, privilege. So much for those English degrees. spelling was never my forte anyway. But this talks about the difference, limited mode and user exec versus full access. All the different configuration modes are shown here. So config, line config, config-line, config-if. We've got how to navigate, moving through it. You can go enable, and this shows you how to go enable and then on down through the different modes.
In this video,
If I'm not mistaken, this is actually Dan Abergetti who teaches CyberOps for us.
We'll look at the enable command, the disable command, configure terminal, exit.
And so I'm not going to walk through those, but basically CompT will get you to global configuration mode. You do interface, the interface. These are in the labs too, so when you do your labs, you'll learn these different modes. But it's just moving around inside of this iOS. Typically, you have a prompt showing you the mode you're in. You have the command, space, and then arguments. Keywords or arguments. If you ever don't know what you need to put next, just use the question mark. I did that this weekend on a Ubiquity router I was trying to set up. And I came within, I was so close. I was one word off from having it correct. I had to call Buddy and finish it up. But the question mark is your friend. So if I didn't know what came after show, I could do show space question mark. And it would give me all the information after show. If I didn't know what was after IP, I could do show IP space question mark. And it would tell me everything that goes with it. And so you can actually use that question mark to help yourself out a great deal. So this has an entire section on the question and features. Now here's one thing I will not suggest you do. Do not plan on using the question mark to get you through the exam for CCNA. You need to know the commands. You're not going to be able to sit there on the simulations and question mark out everything. Now it doesn't mean you won't be able to do some question marking when you have a problem, but just be aware that you won't be able to do all of it. Plus they're bad to turn off certain parts of the help on the test so that you don't have that as an option. Some examples of hotkeys I really like that that are good to know are, I'll show you these real quickly. Oh wait, here's a blank, completely blank packet tracer where I can just grab a router and pull it out here. And so now I've got a router, and if I wanted, I could actually go in here too, pull out a 2960. I could go to the connections, grab a straight through cable, and connect from gigabit 000 to gigabit 01, and now I have a connection here. So you can actually build your own packet tracers. It's something you can learn to do, especially neat to do if you want to do a little test for your students. But if you're doing, let's say you're doing config t hostname, RTR1, and then you do hit the up arrow will repeat the last command, the down arrow will repeat the next one. So hostname, let me do interface GI0/0/0 IP address. Tab will finish your command typically. 192.168.12.1 space 12.0. Spelled, that's why it didn't do it, because I had an extra D in there. And by the way, I could have done this. Instead of doing what I just did, instead of going all the way that way, I could have hit Control A and just moved and been at the very beginning. Control E takes you to the very end of the command. Control A takes you to the beginning. And then I would have done a no shut. Okay, and hopefully that'll come up now. And if I needed to put an IP address on the other interface, the gig 001, I could literally put the up key until I see gig 001, backspace once, type 1, do the IP address, change it to 13.1, hit the up arrow till I get no shut, and then just drag out another switch. Need another switch on the other side here. And I just built, should be no shut here. Yep, now it's up. I just built a functioning network. Now, one of the things that I want you to realize is As we're doing this, we're doing every single bit of this in the RAM. We're doing it in the RAM, the running config. So if I do a dir, you'll see there's no startup config. If I reboot this, I lose everything. So I've got to do a copy running config to startup config, okay? Or you can do it old school, type WR, which means write. Know how to do copy running config, startup config, because that's going to be on the exam. But WR is an old school way of doing it, and it just stands for write. And it writes the settings. And then now I could actually put a PC on each side, give them an IP address, and ping across. You can also do a show IP route. Oops, show IP route. And you'll see my connected routes, the 12 network and 13 network. All right. So Control A, Control E, and up and down arrows are the ones that I use predominantly. I use them the most. Okay. So the rest of them are useful, but tab's extremely useful. That's what you use for partial command completion. The rest of these are somewhat useful, but not as useful. Okay. All right, folks, we are at the end. Here's our hotkeys. As you go through here, you'll keep looking at these different videos. So you've got some time to keep working on these and looking at them. I'm gonna stop. Are there any questions before I stop the recording? Any questions you think other classmates may need to hear or know? Okay, I'm going to stop my sharing, and then I'm going to stop my